Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. On this episode of Global Topic will be a discussion related to antimicrobial coatings. Joining me is Tolga Diraz, who is a protective coating specialist and a lead instructor for SSPC and NACE International. Welcome, Tolga.
Welcome, James. Thank you very much for inviting me to your channel, YouTube channel.
Hey, if people want to find out more information about you, where can they find you?
James, it's very easy. They can find me from LinkedIn, my Twitter account, my Instagram, my Facebook. Actually, they can find me from my website, which is a technical non-profit website, www.corrosiondoctor.org. It's just go there and see the contents, and also the contents about technical things about corrosion and coatings and paints. And me also.
Very good, very good. So, Tolga, let me go open up this episode and talk about what are antimicrobial paints and coatings, and what active components are inside these paints that make them perform as an antimicrobial barrier.
James, as a globally accepted description, antimicrobial paints and coatings are defined as thin films having antimicrobial ingredients that is scientifically proven and applied to a surface to prevent the infection diseases by first killing mechanism, like chemical agent release, contact killing, and secondly, preventing, like anti-adhesion, repelling, and we are killing or preventing the accumulation, growth, and reproduction of pathogenic microorganisms that we call germs, such as fungi, mold, mildew, algae, bacteria, and viruses. So coming to your second part of your question, what are active components? I should say that there are four classes of active components. Firstly, we can say that metal ions, we call it oligodynamic, which means in Latin, small but powerful, like silver, copper, zinc, gold, and its compounds. When you put this metal ions inside the paints and coatings, it basically kills the pathogens, the viruses, but it should be tested. And secondly, the chemical agents like polymers, like cytosine, triclosan, hydrogels, isothiazolone treatments, organic cationic compounds, quaternic ammonium compounds, and enzymes animals all have, like lysosome, acrylase, and titanium dioxide. We all know from the paints, but this is a very special titanium dioxide. Be careful, it's anatase titanium dioxide, which kills the germs by photocatalytic disinfection with the use of ultraviolet radiation. And you can go on.
Okay.
James, this is,
So, Tolga, let me ask this question. What global sectors have the highest demand requirements for antimicrobial paints and coatings?
James, since it's a very critical period of time in the world, all the world, I say most probably the hospitals and healthcare organizations are the most critical places. So, because think of just the United States, there are more than 6,000 hospitals and more than 100,000 intensive care beds alone. And when you consider European side, more than 80,000 patients in 1 year are infected by hospital associated infections or healthcare associated infections called as nosocomial hospital-acquired infections. And because of this, if you ask me what these surfaces needed to be coated, I would say that the primary surfaces should be the hospital walls, doors, trim floors, bathroom ceilings, as well as knobs, doorknobs, handles, handrails, you call it. And because this is very critical in preventing this infections, hospital-acquired infections. And the followingly, this food industry, because we all eat, you know that. I mean, we should eat at least twice a day. So because of the food packaging and food processing industry, basically, all the contact surfaces like aluminum or stainless steel surfaces may have some microbes, germs on it. So let me give you some statistics about food industry. In Korea, there are 1/25 samples obtained by swelling machines are infected. And in also slaughter plants in Taiwan, there are also very problematic places in Taiwan. And in Australia and in Europe, these are very considered very critical surfaces in food contact surfaces. And followingly, high traffic buildings. What I mean by high traffic buildings are universities, institutes, schools, offices, public buildings like library, police, post office, amusement parks, multi-purpose city halls. And last but not the least is public transportation, James, like metro, train, buses. Think of these vehicles are very risky touch surfaces. So you know it, when you get on a train, it's very crowded, or when you get off a bus, it's very crowded, and so you have to touch it. So you need to, these surfaces, these touch surfaces can be painted or coated with antimicrobial coat or paintings or coatings. And they are being coated, by the way.
Very interesting. So when it comes to surface preparation and painting inspection of antimicrobial paints and coatings, is there a difference from normal painting that's required with the use of microbial paints and coatings?
Actually, there are minor differences, James, but these differences may be very important, depending on the purpose of the paint or coating used. For example, if it is used on stainless steel, the surface preparation may be solvent cleaning like SP1, but maybe because of the profile required, it may require an acid etching with a weak acid, like an oxalic acid. So therefore, we should look at the painting or coating datasheet to see if there is a profile requirement. And this is one of the important things, also in normal paints and coatings, but in the antimicrobial, it's much more important. And secondly, when it's come to paint and coating process, yes, you can use brush, roller, or spray, but there are also specialized processes like plasma process, like sputtering, deposition, or cold gas spray, or sol gel method, which are very highly technological processes. For example, in sol gel method, there is a solvent and the gel part, so they make a coating. But in cold gas spray, it's a thermal spray. It's called CGS. It's a thermal spray, but with a high kinetic energy with a low temperature. So this is a specific kind of a thermal spray, let me say. So when it comes to inspection and testing, James, yes, the inspection is basically very similar to normal paints and coatings, but be careful. There is a risk of biofilm, like germs or microbes. So you cannot see it by naked or a normal electronic DFT gauges. You need to use a special instrument or device called 3D laser confocal measurement, which is this device. It measures in the order of nanometers, not in the order of micrometers, in the order of nanometers. It shows the people who are testing the paints and coatings if there's any biofilm left on the surface after applying antimicrobial coatings or paints. So these are also if you want your paint or your coating registered to an organization like FDA, Federal Drug Agency, or Environmental Environmental Protection Agency, or in Europe, biocide product registration, you need to carry out some tests like antimicrobial activity or efficiency tests. These are also described in ASTM, EN, and ISO and Japanese JAS testing standards.
Very interesting.
Okay. Mm-hmm.
So Tolga, we've covered a lot in this conversation. In closing out this discussion, is there anything that we didn't cover with the viewers that you would want to leave with the viewers?
Thank you very much, James. I would like to point out a couple of more details, because firstly, antimicrobial definition, by definition, it doesn't mean killing of microorganisms. Sometimes in the paints and in the formulation, in the technology, there is a repelling mechanism, as I talked in the first slide. So, for example, by exclusion steric repulsion, by electrostatic repulsion or low surface energy, you don't necessarily kill microorganisms, but just repel it, anti-adhesive. So it is a special kind of antimicrobial paint. But you can have biocide releasing or contact active biocide. It's a killing. It's more not well known in today's world, but there is also repelling one. Be careful about. And secondly, there is a risk of disinfection methods, and disinfectants have a risk of deleterious effects on surfaces or paints or coatings. Let me give you an example, James. For example, if you use a chemical like a bleach, you may end up, or like a chlorine, you may end up with pitting corrosion on stainless steel surfaces, because chlorine is an acid, chlorine solutions, and it may create a pitting corrosion. And other than that, for example, if you use some of the metals that we described before, like oligodynamic metals like silver, copper, or zinc, in the formulation or just by spraying with a cold gas spraying, then you may have a corrosion, galvanic corrosion, because, for example, think of aluminum, think of spraying copper on an aluminum surface. There is a risk of galvanic corrosion cell occurring. So in order to prevent this, you may need to use a special primer, biocompatible special primer to prevent this galvanic corrosion on this steel surface, or steel or other metal surfaces. So I think, I mean, this is very, this quotation is, I like it very much, James. We think in generalities, but we live in details, because all the things we covered right now is just the generalities, just the brief case. But there are a lot of details, especially when you go to the internet, you search for internet, all the concepts, you come across a lot of details. And so I hope I have given a good summary or brief summary of the technologies used in antimicrobial paints and coatings.
You definitely have. And I think the thing that, the big takeaway for me when you're looking at antimicrobial paints and coatings is the aspect of not really killing, let's say, microbes, bacteria, but repelling or not allowing them to adhere to the surface. But also, too, we have to be mindful that we have to also protect the substrate as well.
Yes,
and so that by applying these type of coatings and paints can help us when we're using, like you said, cleaning solvents and things like that on these particular surfaces. So it can kind of work in conjunction when we're trying to control in hospitals or schools or other institutions where we're trying to control the spread of, anything from a global pandemic to just a basic, cold or flu seasonal type of activity that happens. Tolga, I very much appreciate the opportunity to talk with you about this topic. And as everyone can see on the screen, there is the website for Tolga mentioned, and also how to reach out and get in contact with him. Also, I'd highly encourage everyone on LinkedIn to connect with Tolga. I've known Tolga for almost 8 years now, and he is an absolute amazing person when it comes to knowledge, but also what's important, hands-on experience. So Tolga, thank you very much for taking the time to talk with me today.
Thank you very much for giving me this opportunity to talk and discuss these issues with you, James. Hope I can help you or get people get benefited from this information.
They definitely will. Hey, Tolga, have a great day, okay?
Thank you very much, James. Have a great day.